Good day, class, and welcome to Mathematics 8. In this video, we're going to discuss the Week 8 lesson, namely, System of Linear Equation in Two Variables. Let's begin. System of linear equation in two variables is a set of two or more linear equations that have variables in common. It is in the form of a sub 1x plus b sub 1y equals to c sub 1, and a sub 2x plus b sub 2y is equals to c sub 2. Take note, your a sub 1 and a sub 2 as well as your b sub 1 and b sub 2 should not be equals to 0. Solutions of a system of linear equation in two variables. These are ordered pairs or coordinates, the value of x and y, that satisfies both linear equations. And take note, there may be one, none, or infinite number of solutions in a system of linear equations. Here are some examples of system of linear equation in two variables. We have the system of x plus y equals 8 and x minus y equals 2. We have the system of 5x plus 2y equals 18, 4x minus 6y equals negative 16, and 9x minus 3y equals 6. We also have a system of 4x minus 3y equals 2, and x plus 2y equals 4. And lastly, a system of 6x plus 2y equals to 13, 8x minus y equals to 21, and 13x plus 4y equals to 2. We are asked to determine whether each ordered pair is a solution of a system of linear equation. If we have 0, 4, 4, 8, 2, 3, is it a solution to the given system of equation of x plus 2y equals 8 and 5x minus 2y equals 4? System of linear equation in two variables are two or more linear equations that have common variables. In our case, we have the variable x and the variable y. We have the linear equations in the form of ax plus by equals c, where a, b, c are real numbers, and a, or the term that contains the variable x, should always be positive.
First on our list is 0, 4. So we just need to substitute 0, 4 to the given system of linear equation into variables. So x will be 0 and y will be 4. So 0 plus 2 multiplied to 4 equals 8. So 2 times 4 is 8, and therefore it is equals to 8. Next, we have 5x minus 2y equals to positive 4. So substitute x as 0 and replace y as positive 4. So 5 multiplied to 0 minus 2 multiplied to 4 equals to 4. And we all know any number multiplied to 0 is 0, and 2 multiplied to positive 4 is negative 8 equals to negative 4, and obviously negative 8 is not equals to positive 4. We can say that 0, 4 is not a solution to the given system of linear equation because it does not satisfy both equations. Next is 4, 8. Let's substitute it to the given equation. Let's have x plus 2y equals to 8. So 4 plus 2 multiplied to 8 equals to 8. So we have 4 plus 2 times 8 is 16 equals to 8. And 4 plus 16 is 20, and obviously it is not equals to 8. Next equation, 5x minus 2y equals 4. 5 multiplied to 4 minus 2 multiplied to 8 equals to positive 4. 5 times 4 is 20. Minus 2 times 8 is 16 equals to 4. So 20 minus 16 is 4 equals to 4. But still, it is not a solution because the 2 or the ordered pair does not satisfy to the 2 equation. It is still not a solution. Let's have the last one. 2, 3. So we have x plus 2y equals 8. Let's substitute. So 2 plus 2 multiplied to 3 equals to 8. So 2 times 3 is 6 equals to 8. So 2 plus 6 is 8 equals to 8. Check. And the second equation is 5x minus 2y equals 4. 5 multiplied to 2 minus 2 multiplied to 3 equals to 4. 5 times 2 is 10 minus 2 times 3 is 6 equals to 4, and 10 minus 6 is 4 equals to 4. Obviously, the given ordered pair satisfy on both equation, therefore it is a solution to the given system of equation x plus 2y equals 8 and 5x minus 2y equals 4.
Since 0, 4 and 4, 8 does not satisfy both equation, it is not a solution to the given system of linear equation. Thus, 2, 3 is a solution to the given equations. Is that clear, class? Yes! Let's continue. This time, I want you to try this one. Determine whether each ordered pair is a solution of the system of linear equation. If we have 2x plus 5y equals 20 and 3x minus 4y equals 7. Letter A, if we have 5, 0, is it a solution in the system of linear equation? Yes or no? How about letter B? 3, 2. Is it a yes or no? Lastly, how about letter C? If we have 5 and 2, is it a solution to the given system of linear equation? Very good. Let's continue. Classifying system of linear equation. To classify a system of linear equations, write the equation in the slope-intercept form, or in the form of y equals mx plus b, and compare their slope and y-intercepts. To classify the system of linear equation, we have this table. We have the graph of equation, number of solution, and types of solution. First on our list is intersecting lines. If we graph the system of linear equation in an intersecting line, therefore, the number of solution is exactly 1 because the point of intersection in an intersecting line is only 1. And if we have an intersecting line, the type of solution is consistent and independent. Second graph, we have coinciding lines or overlapping lines. Since the number of solution is based on the points of intersection, if we have coinciding lines, the number of solution is infinite. And the type of solution is consistent and dependent. Lastly, if we have parallel lines, obviously, there is no point of intersection. Therefore, the number of solution is none. And the type of solution is inconsistent. Again, the graphs of equations are the following: intersecting lines, coinciding lines, and parallel lines. Classifying system of linear equation. If their slope are different, then the system is consistent and independent equation and has only one solution. Therefore, it is an intersecting lines. Second, if their slope and the y-intercept are equal, then the system is consistent with dependent equation and has an infinite number of solutions. Therefore, the graph is coinciding or overlapping lines. And lastly, if their slopes are equal with different y-intercept, then the system is inconsistent and has no solution. Therefore, the graph is a parallel line. Is that clear, class? Yes! Okay, let's continue. In summary, we can use this table to easily understand on how we're going to classify the system of solutions or the system of linear equation in two variables. We have different kinds of system: consistent independent, consistent dependent, and inconsistent. First on our list is consistent independent. The slope is not equal, as well with their y-intercept is also not equal. Therefore, you only have exactly one solution and their graph is intersecting. While it is consistent dependent if your slope and your y-intercepts are equal. Therefore, the number of solutions is infinitely many. Then the graph is coinciding or overlapping lines. And lastly, we have inconsistent system. Therefore, your slope are equal, but your y-intercepts are not equal. Therefore, the number of solution is none, or you don't have any solution at all. Then, the graph is always a parallel line. Let's have an example. This time, we are asked to identify the kind of system of linear equation in two variables and its number of solutions. In the given system of x plus 2y equals 3 and x minus y equals to negative 4. First thing to do is to write the given system of linear equation into its slope-intercept form, or in the form of y equals mx plus b, where m is your slope and b is your y-intercept. So we have y is equal to negative x over 2 plus 3 over 2, and y is equals to x plus 4. Then, copy the value of the slope. So we have negative 1/2 and positive 1. Then copy the value of the y-intercept. So we have 3 over 2 and positive 4. So in the fourth column, we are asked to compare their slope. Is the slopes are equal or not equal? Obviously, it is not equal. Then, compare the value of the y-intercept. Is it equal or not equal? Correct. It is also not equal. Therefore, if our slope is not equal and our y-intercept is not equal, how many solutions do we have? Correct. We only have one solution, or exactly one solution. And once we have exactly one solution, what kind of graph do we have? Is it intersecting, coinciding, or parallel? Correct. It is intersecting. So once we have intersecting graph, what kind of system do we have? Correct. It is consistent and independent system. Is that clear, class? Yes! Very good. You just need to focus on our summary or on our table to answer this kind of question. That will be all for today. Class dismissed.
Wow.